Hello friends, Mr. Burrell here. We're starting our second unit this trimester. We're talking about polynomials. So the reason we start talking about polynomials, this isn't something that you haven't heard before. This is something you've been exposed to before. But we deal with polynomials and polynomial functions all throughout Math 2 and Math 3. If you go on to take higher level math classes like at the college level, you never stop dealing with polynomials and polynomial functions. So, in this unit, we're going to be talking about polynomials. In this lesson specifically, we're going to kind of have an introduction to some basic terminology associated with polynomials, what polynomials are, how we identify them. So by the end of this lesson, these are the things I hope we're able to do. Identify the degree, power, leading coefficient, and constants of a polynomial. Understand that a term is either a single number, or a variable, or numbers and variables multiplied together. We'll talk about terms of a polynomial. I want you to understand that terms in polynomials are separated by plus or minus signs, and be able to classify a polynomial based on how many terms it has. Binomial, trinomial, etc. So, by the end of this lesson, this is what I hope that you are able to do. So, let's review. When you think of a polynomial, what do you think of? When you think of the word polynomial, what comes to mind? Well, a polynomial, when I say polynomial, I'm talking about an expression with multiple constants and or variables combined using addition, subtraction, etc. So this, for example, like 4x cubed plus 4x squared minus 2x minus 3 is a polynomial. It's just a series of numbers and letters with exponents combined together using addition or subtraction. This is also a polynomial. 5x plus 2, numbers and variables combined using addition and subtraction. That's all a polynomial is. So, above 3 terms, if a polynomial has more than 4 terms, we usually just call it a polynomial, like a polynomial with 4 terms. With 3 terms or less, there's some specific names, specific terminology we usually use to identify those kinds of polynomials. So a monomial, like a monocle or something like that, monomial means it has 1 term. So things like 3x or negative 3 or 4xy squared z. 1 term, meaning one thing, one section of stuff being multiplied together. So 4 times x times y squared times z. Negative 3, 3x. Those are all monomials because they have 1 term. A binomial, or like bicycle or bifocals, has 2 terms. So 2 terms separated by a plus or minus sign. So like 3x minus 5 would be a binomial. 4x y squared z plus 3ab, that would be a binomial because I have 2 terms being added or subtracted together. And then a trinomial, like tricycle or trifecta, has 3 terms. So 3 terms separated by addition or subtraction. So 4x squared plus 2x minus 3. Here's 1 term, 2 terms, 3 terms, separated by addition or subtraction. So monomial, binomial, trinomial is 1, 2, and 3 term polynomials. Anything above that we just denote as like a 4-term polynomial, a 5-term polynomial, etc., etc., etc. Okay? Okay, let's go ahead and talk about some other terminology, some other helpful tips and tricks associated with polynomials. So the degree, if I'm looking at a monomial like this, the degree of a monomial is the sum of all the exponents in that monomial. So, for example, x to the 4th has an exponent of 4, so the degree would be 4. This would be a 4th degree monomial because it has an exponent of 4. Here, 3xy to the 3rd, x here has an exponent of 1, y has an exponent of 3. If I add those up, I get a 4th degree polynomial because the exponents in that term add up to 4. If I just have the number 6, notice 6 doesn't even have a variable, so it has 0 exponents. If I had a variable here, it would have 0 exponents. So this would be a degree 0. So this is a degree 4 polynomial. This is a degree 4 polynomial. This last one is a degree 0 polynomial. So the degree is the sum of all the exponents. So the degree of a polynomial, so if I have multiple terms, notice these ones all had just one term. If I have multiple terms, the degree of the polynomial is the highest exponent, or it's the monomial with the highest degree. So like if you look at this polynomial here, I have an exponent of 1. Here I have exponent of 0, an exponent of 4, an exponent of 2. So since this one right here is the biggest or highest exponent, the degree of this polynomial, this would be a degree 4, or a 4th degree polynomial, because the largest exponent is a 4. Okay. Okay. Standard form of a polynomial is when the polynomial is in descending order by degree. So for example, looking at this polynomial right here again, we had a term that was degree 1, degree 0, 4, 2, etc. So if I were to write that in standard form, I just write it with the exponents, or the degrees, going from biggest to smallest. So I wrote that degree of 4, and then 2, and then 1, and then 0. I write it from the biggest exponent to the smallest exponent. So when I say to write a polynomial in standard form, that's what I'm referring to. A coefficient, when I talk about a coefficient in a polynomial, that's the number in front of the variables. So like in these cases, these are exponents, the numbers hanging out up here, these powers, we call those exponents. These numbers in front of the variables, or the numbers by themselves here, those are called coefficients. So the numbers in front of the variables are coefficients. And the leading term, if I'm looking at a polynomial in standard form, the leading term is the term of highest degree, or the first one, the leaderboard term. And its coefficient is called the leading coefficient. So if I write this polynomial in standard form, this is the leading term, this is the leading coefficient. Okay? So these are just some general terms to help us identify and work with polynomials. Kind of know what we're looking at, be able to identify them, know what we're working with here. Okay? The last term we want to discuss is the constant term. Using this same polynomial, the constant term is the term without a variable. So this 6 over here that does not have a variable attached to it, we're going to call a constant. So these definitions are all in your guided notes. I would recommend writing down some examples of what those are so you can remember them. So let's go ahead and take a look at this polynomial. I have negative 3x to the 4th minus 4x squared plus x minus 1. So this has 1, 2, 3, 4 polynomials. Or 4 terms, sorry. So I'm going to call that this is a polynomial with 4 terms, okay? The degree of this polynomial is the largest exponent. So I have a 4, a 2, this has an exponent of 1, this has an exponent of 0. So since the largest exponent is 4, I'm going to call this a 4th degree polynomial, or a degree 4 polynomial. The coefficients in this polynomial are negative 3, negative 4, 1, and negative 1. Negative 3, negative 4, there's an invisible 1 in front of this x, so this coefficient is 1, and then I have this negative 1. Those are my coefficients. The leading term is the first one when it's in standard form, which it is. So the leading term is negative 3x to the 4th, and the constant term is negative 1, or the number without a variable attached to it. Okay. So, oh yes, we talked about, I just mentioned, the leading term is negative 3x to the 4th, and the leading coefficient is the number in front of that x, so negative 3. And then the constant term is negative 1. We were correct. Are there any missing terms? Are there any degrees that are not represented? So notice I have a x to the 4th term, an x squared term, an x, and a constant term. Right in here, there could be an x cubed term. But that's missing right here, which is fine. It doesn't need to be there. But we recognize that this is a degree 4 polynomial without an x cubed term. So we're just recognizing, again, we're just looking at these polynomials, trying to identify as many things about them as we can. Okay, so have some polynomials here. My instruction is to write them in standard form and then state the leading coefficient and state the constant. So if I write this in standard form, for example, I need to write it with the largest exponent first. So I'll write this 4x to the 5th minus 3. 4x to the 5th minus 3. The leading coefficient is the coefficient in front of the first term, so the leading coefficient is 4. The constant is the number without, or the term without a variable, so the constant is negative 3. This next one, if I'm writing this in standard form, I need to write this term first because it has the largest exponent, then this one, and then the constant at the very end. So I'm going to write that as 8x cubed minus 2x squared plus 3x plus 4. The leading coefficient is the first one here, so the leading coefficient is 8. And the constant is the term that doesn't have a variable, which is 4. I would do this same kind of thing here. Just riddle me this for a second. What if I just had the polynomial 8x cubed minus 2x squared plus 3x? What would the constant be in that case? Well, if there's no constant, the constant would just be 0. Okay? All right. So let's take a look at these. Name the polynomial by degree and number of terms. So this is similar to what you'll see on your homework, what you'll see on the test. 3x to the 4th, the degree slash number of terms. The degree is the largest exponent. So this is a 4th degree. This is a 4th degree polynomial. And how many terms are there? Just one, so I will call that a monomial. So this is a 4th degree monomial. The leading coefficient is the number in front of the first variable, which is 3. The constant, in this case, is just 0. Okay, next one. The degree of this polynomial is the largest exponent, which is a 2. So this is a 2nd degree polynomial. And how many terms are there? 1, 2, 3. So I'm going to call that a trinomial. This is a 2nd degree trinomial. What's the leading coefficient, or what's the very first number in front of the first variable? Well, that's a 5. So the leading coefficient is 5. The constant is the number all by itself without a variable, which in this case is 1. Okay, we'll do one more here. This one right here, it says, well, let's do this one right here. This is 9 plus 7x cubed minus 4x. What's the degree of this polynomial? Well, I'm looking for the largest exponent. So this is a 3rd degree polynomial. And then how many terms? What's the number of terms that I have? 1, 2, 3. So this is a trinomial, just like the second one there. What's the leading coefficient? Well, some of us are tempted to say 9 because it's the first number, but this polynomial is not in standard form. When I put it in standard form, remember that the leading coefficient is the term in the number in front of the leading term, or the one with the largest exponent. So the leading coefficient is 7, and in this case the constant is 9. So that's what you can kind of expect to be doing on your homework assignment / on this section of the test. So, just as a side note, why polynomials? Why do we talk about polynomials? Why are we introducing this right now? Well, this guy, I think you pronounce his name Diophantus of Alexandria. He was born in like 215 AD. He's considered the father of polynomials. He did a lot of work focusing on using polynomials in the context of solving algebraic equations. So people use polynomials based on his research and research since to model roller coaster designs, in economics to do like cost analysis. People in like the physics and chemistry fields, we use polynomials to measure acceleration, electricity, write down chemical equations in chemistry. There's lots of applications where we use polynomials. So this is just an intro. We're going to talk a lot more about polynomials in this unit. But hopefully now you can identify the degree, the leading coefficient, and the constants of a polynomial. Understand that a term is either a single number or variable, or numbers and variables multiplied together. Understand that polynomials are separated by plus or minus signs. And then classify a polynomial based on how many terms it has, like a monomial, binomial, trinomial, etc. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. I hope that you enjoyed that as much as I did.